Hello, let's solve more examples of one-step equations. We are on page 18. This is practice B. We're still in the beginning of book, chapter 1.2. So let's consider a few examples here. Let's consider B, let's consider D, and F. Just one half of what we get here. Maybe the right column. And then we will do more examples. So let's again use the same strategy of isolate the variable. Let's be reminded one more time that what we're trying to do here is, whether it's a variable k or p or h or any other letter that they use, we want to make sure that it stands by itself on the left-hand side of the equation, and on the right-hand side we have hopefully a solution, right-hand side. So these are the notations, right-hand side I use, and both are equal. So k minus 5 equals to 6. What minus 5 gives us 6? I'm sure you can solve it in a heartbeat, but that is not the point. The point is to understand how we isolate the variable. We want k to be standing by itself on the left-hand side, just like that. K equals, well, what is in the way of k? We have this minus 5. To get rid of it, we use opposite operation. Minus 5 plus 5 will reduce to 0. According to the rules of the equations, what we do to the left, we must do to the right. So we must add 6. Oh, so sorry, not 6, of course, it's plus 5 to both sides. 6 plus 5, so on the left-hand side, we have this variable k all by itself. Here it is. And on the right-hand side, we end up with 6 plus 5, which is 11. Okay, so what minus 11? It was k minus 5 gives us 6, right? And of course, k must be equal to 11. Next example, D. 12 minus p equals 7. 12 minus what will reduce that number to 7? Again, we use the same method. We're trying to isolate the variable on the left-hand side. So let's start with minus p. Let's start with minus p. Minus p on the left. How do we get rid of this 12? How do we get rid of this 12? We must subtract it, right? 12 minus 12 will reduce to 0 on the left-hand side. What we do to the left, we must do to the right. 7 minus 12 on the right gives you negative 5. And we're not done, because this is a negation of p. Negation of p. We do not need to solve for negative p. We need to solve for positive p. There is, of course, we can multiply both sides by negative 1. I'm not going to too many details on this yet. Let's just say we will negate. So negative p turns to positive p, and minus 5 times negative 1 becomes 5. P equals to 5, which I'm sure you knew the answer. I know this is a very cumbersome way to solve 12 minus p equals 7, but we are learning the mechanism of how we isolate the variable. Next example, F. 9 minus h equals to 1. Well, how do we make h stand by itself? Let's start with negative h, right? Negative h on the left-hand side. We must get rid of 9. Minus 9, right? That's your opposite operation. 9 minus 9 gives us 0 on the left. What we do to the left, we must do to the right. 1 minus 9 gives you negative 8. Now, that's negation of h. Therefore, positive h will be equal to positive 8. Now, down below here, I want to skip a few examples, and I want to draw a line right here and focus on number 5. Focus on number 5. We have multiple examples here. Let's just solve B, D, and F. And the rest of them you can solve, you can tackle on your own. 4m equals to 12. Well, let's divide by 4 on both sides. Let's divide by 4. What we do to the left, we must do to the right. So m is equal to 3. M divided by 12 equals 4. How do we make m stand by itself? We must use opposite operation. 12 times on the left times 12 on the right. So on the left-hand side, 12 and 12 will cancel each other out. We will have m standing by itself. And on the right-hand side, 4 times 12 is 48. Let's check if our answer makes sense. Is 1/12 of 48, or 48 divided by 12 gives us 4? Yes, 48 divided by 12 is 4. Finally, example F. 12 minus what gives you 4? Again, I know you're going to tell me that m must be equal to 8, and you are correct. But if we do use the same strategy, the same method of isolating the variable. First, get rid of the 12 on the left, reduce it to 0. What we do to the left, we must do to the right. 4 minus 12. What do we have? We have minus m, or negative m, equals to negative 8. Yes, that's just a negation. Let's negate that answer to get the positive m, and m is equal to 8. I hope these examples helped you.